Hello and welcome back to my channel Learn with Nikhil. So in this video we have taken another sum on isometric projection where we have been given the front view and the top view and we have to draw its isometric view. So first the point O, as you can see from the point O on the right side, as we have the longest length, so accordingly we will plot the point O here so that the right side I have the maximum space. Now next, total width of the front view, that is 35 plus 15 plus this distance 35 and the radius 35, so total is 120 millimeter. Then the depth of the figure is 20 plus 20 plus 30, that is 70, and the height is, that will be the radius or the diameter of the entire semicircle, that will be 35 plus 35, that is 70 millimeter. So as we have got the three dimensions, now using these dimensions we will plot the rectangular box. First we will draw a straight horizontal line. We'll mark the point O. Then from the O on the right side, as you can see, we have to draw its front view. Now we will draw the angles, that is 90 degree, 90 degree, 30 degree, drawing light lines through them. Now here we have a total length of 120. As this is point O, on the right side we have 120 millimeter. So that's why we had left maximum space on the right side. Height is 70 millimeter, this height is 70 millimeter, and the depth again is 70 millimeter. Now using these three dimensions we will draw a rectangular box. Draw the lines parallel properly. While drawing, do check whether we have drawn the parallel lines properly and we have got the dimensions properly. Now starting from the point O, as you can see, we have a total distance of 50 millimeter, that is 35 plus 15. We have a dark line. We have this angle part, we'll do it later. So first this distance total, this is 35 plus 15, that is 50, and that is a dark line. So this is 35 millimeter, and after 35 millimeter 15 millimeter, so total is 50. Make a dark line here. So this distance is 50 millimeter from the top, and from the front view you can see. As you can see, this height, as you can see from the diagram, it is literally the half of the entire diagram, that will be around 35 millimeter. But you don't have to assume like this. I'll show you the exact way how to calculate that. I'll show it later, that how much height it is. We will do it with the proper method, so we'll do it later. Now moving towards this part, here you have a height extension, that is a straight dark line. So I'll draw this line. This is this line, as there is a bend from here. Then you have a extension forward of 15 millimeter. So from here 15 millimeter, make it dark. Now from here we have a slant line, we have an angle over here. So how to draw it? So first we have to plot this part two-dimensionally. So I am drawing here separately the two-dimensionally. We have to find the height. So this distance is 50. So we are plotting this two-dimensionally on the side. So we can find out the height. Height is 70. This distance is 15. Now here we can plot the angle. We can't plot the angle in three-dimensional, we have to do it in two-dimensional. So here I will plot an angle of 45 degree. Just mark the perpendicular line so that I'll be able to plot the angle. So 45 degree angle. Drawing this part, and then from this end drawing it straight upward. So this is how I can find the distance. So this height I have to find out, as it is not given. I'll just plot the dimensions first, so you'll understand which diagram I have drawn here. This is 45 degree, This distance is 50. In the exam also you have to draw this, which will show that you have calculated it. This height is 70. Now measuring with the scale, this dimensions comes to 35 degrees. So this is how you have to find out the dimension. I'll just mark it over here. So this we have found out by drawing it two-dimensionally. This is 35 millimeter. So now this height I'll draw it as 35 millimeter. Draw it dark and join this. So this is how this part is drawn in three-dimensionally. Now the same thing is plotted over here also, as it is totally same on the other end as well. As you can see here, we have a gap. You have a distance of 20-20 and you have a gap. So first I'll plot this part, the same as we have drawn here. I'll draw it here also. This height is 35. Taking this as the reference line. This is the dark line, total dark line. So here we have a total dark line. So this is the dark line. This is this point. Joining this. Now this is 15 distance. As you can see, I'll draw a light line here as it has a gap of 20-20 and the center part. This dimension is not given, but the center dimension given is 20. So this is 20. So I'll mark the center point, and from the center 10 millimeters on both the end. So that will give me the center block as 20, and this part is dark. The center part of 20 is left blank. Now here, as you can see, it is a drilled part from top to bottom. This distance given is 20-20, and then you have again an angle of 30 degree. This also you have to plot the same way as we have did earlier for the 45 degree. I'll show you. First I'll mark this dimension. This is 20. This is 20. And the center part blank is 30. Now this is how it is cut from top to bottom. It is cut on the slant part as well. So it's a bit tricky to draw. Now first it is cut at a distance of 15 millimeter. As you can see, this part is 15 millimeter. The depth of the cut part is 15 millimeter. So from here I'll project the light line upward, taking this as the parallel reference line. I'll project this line here. So this is how we have drawn the depth of the cut part. So as it is totally drilled from top to bottom. So from here I'll just draw a light line upward as it is cut vertically. This is the dark part. Making this part dark. So this is the front side, just the front side of the cut part, but we have yet to draw the angle part. So this angle part we have to draw. Now here we have been given 30 degrees. So again we have to draw it two-dimensionally, this whole part. We have to find this distance. So this distance is unknown. Once you find this distance, we can easily plot in three-dimensional. So now here I'll just draw the whole thing. So this angle part I'll draw it. So first I'm drawing it horizontally. In the diagram it is vertically. So first this is the 30 millimeter distance. So this is this gap. I'm drawing, this is 30 millimeter. Then we have to draw the angle, that is 30 degree. So this is the 90 degree part, and from 90 degree left side 30 degree. So first I'm marking the perpendicular line, so it will be easy for us to plot. So perpendicular line, so from here 30 degree, so this is 30 degree, and from here also from top 30 degrees, so this will be that. So drawing here lightly, I'm not extending till the point as we just require little part. So this I have drawn it horizontally. This is 30 millimeter. So this is the gap. We have drawn the angle. Angles on both the side is 30 degree. Here also and here as well. Now this gap is 15 millimeter. So I'm just marking the point. So this is 15 millimeter gap. Now I'll draw a parallel line through it. So this we have created it two-dimensionally. I'll just mark the dimension. So this height is 15 millimeter. Now with this we have got the dimension which was required. So as you can see, this total dimension was unknown. So we have got. So the total dimension is around 48 millimeters. So we will plot this dimension. So before plotting we will just mark the center point line. So as it is at the center, so I'll just mark the center line. So this is 30, so the center point will be at 15 millimeters. So from here just I'll mark the center line. Now the same I'll plot it here. So the half of this 3.5. I'll take this as the parallel reference line. I'll draw a line here. So this is totally divided into half, and it is divided on the slant line as it is cut on the slant part. Now I'll just measure. The half of it will be around 2.4 as the total is 4.8. You can take your own dimensions there when you draw it. So marking here around 2.4 from the center on the left side as well, around 2.4. So this is how we have got the total dimension which we were finding out, joining this part from here, joining till this part. So this is the cut part in 3-dimensional. Now joining this dark, as it is cut from the top to the bottom, it is totally drilled from top to bottom. So there will be internal cuts also. So taking this as the reference line, drawing it here, the light line, until where it is cut inside, it is around 15 millimeter. So 15 millimeter from here, the reference line, this is cut depth, drawing it dark. Now joining this and joining this. So this is how it is cut. You can take this as a reference line and join this. So this part is done, the front part. Now the back side, as you can see, you have a semicircle from here. Now for drawing the semicircle, you know the procedure. Circle or semicircle, you have to draw a rectangle or a square of sides as a diameter. So the radius given is 35, so the diameter will be 70. So this distance is already, this is 70 millimeter. So we'll draw a rectangle on this plane. Now taking this as a reference line, from here 70 millimeter below, marking, then drawing a parallel line from here 70 millimeters on the left side, taking this as the parallel line, and from here 70 millimeters below. So this is the whole rectangular or a square box of side 70 millimeter. Draw it lightly Now the procedure of drawing the semicircle: join the longest diagonal. This is the longest diagonal. Then from the shorter diagonal, joining at the opposite ends at the center point. So marking the center point from here, join from here, join at the center point. Now here also we have to join at the center point, but I'll just mark the point. As for the semicircle, we require only 2 points to draw the semicircle, and we already have it. Now taking this as the radius, draw the curve, draw it dark, keeping the pointer here, take this as the radius, complete the curve. So this is how we have drawn the semicircle. So this is the semicircular part. Other lines you can draw it dark. So draw this part dark, bottom till this part only will be dark, as the other part is hidden behind, so you need not to draw it dark. Now the thickness given is 20 millimeter, so from here I'll draw a light line. Now you have to project the point from where we have plotted on the left side. So I'm projecting this end, the center point, I'm projecting it 20 on the left. This part also I'm projecting a light line. This is already projected. Now the center point, I have projected it 20 millimeters on the left side. So first I'll take this as the radius, the curve, projecting it 20 millimeter on the left on this line we have drawn, and then drawing the curve. So this is how we draw the curve. The start and the end of this curve we have already plotted, as you can see. Now joining this dark, and we are done with this part, joining this dark. So the outer semicircle is done. Now inner, again we have a circle, the same procedure. The diameter given is 40 millimeter. Now first we will locate the center point, and from the center point 20 millimeters on each side we will find, as it is totally drilled at the center. So first I locate the center, 35 millimeter. I'm drawing a light line. This is 70, so marking the center point. So this is the entire center point. Now from here 20 millimeters on this line, 20 millimeters on here, taking this as the reference line. From here drawing a line. So from here 20 millimeters above and 20 millimeters below, drawing a rectangle. So this is how we have drawn a square of side 40 millimeter. Now final, again the diagonal line is already present. From the opposite ends, joining at the midpoints of the opposite sides. As there are many lines, just make the center points dark. So this is the point, this is the point, and finally this is the point. So from these 4 points we will draw the circle. You know the process. Now here, as you can see, it is hidden behind, so I'm not drawing the entire curve. Only the part which is visible we have to draw it. So this radius, and here also only this part, this much part is visible. So I'm drawing this part only, keeping the pointer here, and finally drawing this curve. So this circle is drawn. Now as this circle is drilled inside with the thickness of 20 millimeter, so its thickness is 20 millimeter, so the cut line will also be visible. So for drawing that cut line, we'll take this as the reference line. I'll just project the point, the curve which we have drawn. So this, from this point I have drawn the curve. I'm just projecting it behind at a thickness of 20 millimeter. I'm marking the point. Now from this point we have drawn this curve, so I'm just projecting it backward and drawing this inner curve. So this is the inner cut, so it will be visible. So this is how we have drawn the entire sum, and we are totally done with it. Just mark off the front view. So this is the front view. Take this as the reference line and mark an arrow X, and then go for the dimension marking. All the dimensions which are given, just mark them in the figure, and we are done totally. Thank you for watching. Do subscribe to my channel. If you have any doubts, any queries, let me know in the comment section. You can also connect with me on Instagram.